Hello guys, welcome to Leetcode. So today we are solving the problem on the Leetcode POTD. The problem is the minimum number of the move to seat everyone. It is an easy level question. Let's read what the problem statement says. There are the n seats and the n students in a room. You are given an array seats of length n, where seats of I is the position of the ith seat. And okay, so you are given a two array. One is a seat array, another is a student array. One is a seat array and another is a student array. Both are of size n. You are also given a students of length and the student of A represents the position of the jth student. Okay. Okay, then this is seats array, the ith element of the seats array represent the position of the seat, and the ith element in the students array represents the position of student. Okay. Okay, our task is to perform a operation any number of times. You can either increase or decrease your position of the ith student by one, moving the ith student from the position x to position x plus 1 or x minus 1. Okay. So your our task is to perform the operation any number of times. Okay. And the operation is that you can either increase or decrease the position of the students by one. Okay. It means that if the current position of the student is x, then you have two options. Either you can increase it by one and then move the position to x plus 1, and either decrease it by 1. You can move to the x minus 1 position. Okay. So return the minimum number of the moves required to move each student to the seats such that the not students are in the same seat. Okay. Then here is the seats array represents all the seats, and we want to assign all the students the seats such that no two students are standing on the one seat. No two students are standing on the one seat. So we have to assign the unique seats. Okay. That is the first observation that you have to do. That we have to assign the unique seats each student to each students. Okay. That's the thing. Okay, let's check for the example test case. Let's check for the second example test case. 4 1 seats are the 4159. Seats are the 4159. This is our seat array, and now comes to the student array. 1326. 1326. This is our student array. Okay. Now what you have to do is you have to assign each student a seat. Okay. I can assign one, that any number, any seats between these. Okay. But this seat is at the 4. Then if I want to assign the student 1, let's say this is a student 1, this is a student 1, this is a student 2, this is a student 3, and this is a student 4. Let's say I'm currently at the student 1 place. If I want to assign a student 1 the seat number 4, then what position I want to move the student 1 to get the seat number 4? So I want to move the plus 3. Okay. Plus 3, so that there is a number of the operation is 3. Okay. Then what the number of operation is 3. Okay. Number of operation is 3. Now comes to the student 2. Student 2 is currently standing at the position 3. Then suppose that I want to assign this seat to student 2, then what I have to do, I have to decrease 3 by 2 so that he get the first seat. So I have to decrease it by 2. So decrease it by 2 takes the 2 number of operation, because in one operation we can either decrease or increase the position of the student by only one. Okay. So now let's say I am currently at the student 3. Student 3 is currently standing at the position 2. Okay. Then at the position 2. Now I want to assign this student this chair to this seat to this student. Okay. Then what will I have to do? I have to increase the 2 till 9. Then I have to increase the 7. Okay. So what is the number of the operation required is 7. And then the 6, then I will come to student 4. Student 4 is currently standing at the position 6, but the available seat is at the position 5. So what I have to do, I have to decrease the position of the student 4 by 1. So I have to decrease it by 1, so it will take the one number of operation. Then I will sum it up the whole operations. Then it will become 3 plus 2, say 5, and 5 plus 7 is equal to 13 and 14. So this is a 14. Okay, so this is a 14. But I want to minimize this. Okay, I want to minimize this number of operation. Then what is the best optimal approach to do this? If I am currently, if my ith student is standing at the position x, let's say I am currently, my current student is position at x, then what I have to do, I have to check in the range such that the which seat is available nearest to my x. Okay, which seat is nearest to my x, so that I can assign this seat to this student. Okay, uh, suppose that my seats is available at 1, 3, 5 and 7. Then if my current student is at the second position, then I will check in the range of the seats are available. Then I will assign the minimum string that is available. Okay, minimum position, nearest position that is available. Okay, then I will assign the minimum position that the seat is available. Then I will assign that student. Okay, so here is the 1 is the nearest and the 3 is the nearest. Then what will I do? I will simply assign either of them to this student. Then I will uh, this seat is occupied. Now I have my 3, 5 and 7 positions. 7 position is empty. Then if my currently my next student is standing at the, let's say, the third position, then what I have to do, I have to check for the remaining available seats in the range of the 3. Then if he is standing at the third position, and also there is a seat which is at the third position is empty, then I will simply assign this thing to this seat to this student. Okay, okay, so that's how we can do this. So firstly, that's come to my mind is I have to sort the seat array. So let's check for the sorted seat array 4159. Then the sorted seat array is 1459, and my students array is also, so it I will also sort my student array. Then 1 2 3 6. Okay, 1 2 3 6, 1 2 3 6. Okay, then what I have to do, this is my student array and this is my seat array. Then what I have to do, I don't want to check in the range because I have now sorted the both array. So what I have to just do, I have to just simply check of the seat that is available at the ith index. So it is proven that it is the nearest string within the student's position. Okay, this is also a pair of the students with the same seat. This is also a pair and this is also a pair, and it can be proven that this ith student is only ith student. The nearest chair, nearest seat empty is possible is the only at the ith seat, ith index of the seat. This is holding true for after for the every index after the sort. Okay, remember this after sorting. Now what I have to do, I have to simply take the differences of all this. So this is a 0, this is a 2, this is a also equals to 2, this is equals to 3. Then I will sum it up to, because I will take the absolute difference. So it will either decrease or increase or decrease, but my operation will always remain increasing. Okay, so I will take the absolute difference of both of these. So this will the 3 2 5 6 7. Okay, 7. Then the answer is 7. You can see the answer is 7. Okay, so that's all about it. What is the time complexity? Time complexity is we have to sort the first array, seat array, and the second student array, but both are the same size of, n. Then the time complexity is order of n log n for the first seat array to be sorted, and another n log n for the student array to be sorted. And then I want to take the absolute difference of each and every element. Then it will take the big order of n. So the time complexity can be approximated to order of n log n. Now, what comes to the space complexity, I have doesn't use any extra space, so the space complexity is big order of 1, and then the time complexity is order of n log n. So this is all about this algorithm. Now comes to the coding part. So we are given the seats array and students array. So firstly, what I want to do, I want to sort these both arrays. Dot begin dot end. Okay, I have sorted my seat array. Now I want to sort my student array. Sort students dot begin to students dot end. Okay, now I have sorted my student array. Then what I have to do, I have to simply traverse through the whole array. Okay, I'm traversing through the whole array. Then I'm taking the absolute difference of these seats array, comma, this student minus the student array. Then I will simply add it to my answer. Number of operation, let us say number of operation, and I will initialize my operation to 0. And at the end, I will simply return my operation. Let's check if it is running fine or not. Okay, running fine. Now comes to time complexity. This will take big order of n log n. This will also take a big order of n log n, and this for loop takes big order of n. So the time complexity of the whole algorithm is big order of n log n plus n log n plus n, which is approximated to big order of n log n. And what is the space complexity? Space complexity is big order of 1 because we are not using any extra space instead of this variables, integer variables. So it will take constant space. Let's submit it. Okay, accepted. So this is all about the minimum number of moves to seat everyone. Okay. Thanks for watching. See you tomorrow.